welcome back to Advent of Code 2015. I accidentally did day 3 without recording, so that's why it's already unlocked, but I'll go through it now once more. Day 3, perfectly spherical houses in a vacuum. Santa is delivering presents to an infinite two-dimensional grid of houses. He begins by delivering a present to the house at its starting location, and then an elf at the North Pole calls him via radio and tells him where to move next. Moves are always exactly one house to the north, south, east, or west. After each move, he delivers another present to the house at its new location. However, the elf back at the North Pole has had a little too much eggnog, and so his directions are a little off, and Santa ends up visiting some houses more than once. How many houses receive at least one present? For example, East delivers presents to 2 houses, one at the starting location and one to the east. Northeast Southwest delivers presents to 4 houses in a square, including twice to the house at the starting and ending location. And then toggling North South delivers a bunch of presents to some very lucky children in only 2 houses. So how many houses will receive at least one present? What we can do is take an example and put it into our input and get going. So first, we only have one line of string, so I just take this first line from my file and put it into raw. For each character in this raw string, we can see what we want to do based on the character. If it's east, we want to do something. If it's east, we want to update our position and store the position we're at. What we can do is we have a current position. Let's say Santa position is, I'm thinking of this as a 2-dimensional grid with 2 coordinates, and we can walk in each direction. North and south is here, and east and west is here. And we store all the positions in a list. We can just start by already storing Santa's position. So we have a mutable list of pairs of int, and then if we go east, we update Santa position. There's a new pair with Santa position dot first and Santa position dot second +1, and then we can go west, where we would go -1 in the second dimension. Then we can go north, where we would go in the first dimension, maybe up, and then south is going increasing the first dimension, so we go plus minus plus. After we updated it based on the current character, we can add the position into the list. Now if we take the list of positions after we went through all characters and check the size of the list, then we would see all the positions we visited, but we only want the unique positions that we visited, so we could do something like this, distinct size. So how many distinct pairs have we visited in this grid? So if I run this, I should get 4. Yeah, I'm getting 4, because we start with one present, go north and east and south and west, back to the starting point, and we get 4. So if I get my input, put it here, then we get 2572, and that's the correct answer, 2572. Okay, part 2, the next year, to speed up the process, Santa creates a robot version of himself, Robo Santa, to deliver presents with him. Santa and Robo Santa start at the same location, delivering 2 presents to the same starting house, and then take turns moving based on instructions from the elf, who is eggnoggedly reading from the same script as the previous year. This year, how many houses receive at least 1 present? So now they take turns. First Santa goes north, and then Robo Santa goes south. So that gives 3 houses. And then Santa goes north, and then Robo Santa goes east, and then Santa goes south, and then Robo Santa goes west. So they're just moving between the starting position. Santa goes north and south, and Robo Santa east and west. So it's only 3 houses. And now Santa keeps going up, and Robo Santa keeps going down. So in the end, this example gives 11 houses. So let's check it. What can we do? We already have Santa position. We can do Robo Santa position. Same starting point. We already have that starting point in our list here, so we don't have to add it again. And then what we can do is maybe put this into a function with Command Option M. Call this update position. So we update the position based on the character and give it a position. And then go through this whole process. Kind of doesn't need to be called Santa position. Let's just say position. And then, so we just update this position, return it, and then store it in, well, currently we store it in Santa position. But now we want to only get every second character for Santa and every second character for Robo Santa. So what we can do is find out which character is first or second by getting the index, the for loop, and then we can check if or when. The index that we're currently at is 0. Then we're Santa. Every second time we go through the list, this is true, and then we want to update Santa position. And also that's when we want to add Santa position. And in the other case, offset by 1 every second time, we want to get Robo Santa position, update this position, and add that to our positions list. And then we can once again check the position's distinct size, and we get 11, which is what we wanted here for this example. So now if we check our real example, real input, then we have 2, 6, 3, 1, and that's what we want. So that's it for day 3. Thanks everyone. See you next time.